Hello guys and welcome. I hope that you're having a good day or good morning or good evening. My name is I play 4K, aka I play 8K, aka I play 16K or UHDking. During this video I'm going to show you Star Wars Battlefront II PC game running on a single Titan RTX video card equipped with 24 GB of VRAM GDDR6 and old school Xeon E5 2697 V2 CPU with 32 GB of system RAM, 4 sticks of 8 GB running a quad channel 256-bit. I know it's an old school CPU and I'm using this as my workstation in 2020. So this is I play 4K or UHDking workstation for 2020 that doing the 8K resolution video encoding and transcoding as well as 3ds Max video rendering. Okay, so this is not my gaming PC. I'm going to show you on my gaming PC for 2020 and 2021 running on a single Titan RTX and on 2 Titan RTXs in SLI, as well as I'm going to show you on this Xeon E5 2697 V2 on 2 Titan RTXs in SLI. The reason why I'm showing it to you because this is a great low budget system as workstation, or it can be all-in-one low budget system where you can use it as workstation as well as the gaming rig. And today I'm going to demonstrate it to you. So this video will be a little bit longer than usual. I'm going to show you 4K resolution, then I'm going to show you 1440p as well as 1080p. And in the end of this video I'm going to show you the CPU-Z, GPU-Z, MS Afterburner, IDA64, all kind of different benchmarks, and we're going to talk more about the PC hardware in the end of this video, and I'm going to show you some facts. So this is how we're going to run it. I'm going to show you just some presets. Okay. We're going to start with Ultra. Going to press the pause button if you need to, and field of view will be 110 degree. Maximum field of view. All right. The reason of this video is not the gameplay. The reason of this video is to show you the performance as a benchmark so we can compare it with the future PC systems, video cards and CPUs. This is how I'm going to run it, completely maxed out on the server. And let's go ahead and have a look, shall we? And at the right top corner, as you can see, I have the display information system. Through the MS Afterburner, it's a custom display information system, self-explanatory, plus the main names of my projects that I'm running. SLIready.com is going to be a great project when I'm going to show you how to enable 2 or more video cards in SLI when game doesn't support SLI by NVIDIA driver. Alright, so stay tuned for that, and guys, don't forget to smash that like button to support me. Visit my sponsors. A lot of time, money, energy is dedicated to this, and hopefully it's going to bring you a value, especially for those folks that building use like new computers, low budget. This is going to be a great topic. Alright, so I'm just going to play with the heavy. I'm not going to switch characters or classes. I'm just going to play one class, but the game, as you can see, has the 4 classes. Pretty much the game is like Battlefield kind of style of the game, which is nice, and beautiful visuals, by the way. This game was released to the public in 2017, so I'm assuming it's running the same game engine, Frostbite game engine, as Battlefield 5, which is utilizing a lot of CPU cores. Okay, and that's why I decided to go ahead and keep the 12 cores, because the Xeon E5 2697 V2 CPU comes with 12 cores and 24 threads when hyper-threading technology is enabled. Guys, please keep in mind that I'm coming in real time. It's kind of hard to play and comment and look at the digits at the right top, but you want to be focused at the right top. As you can see, my GPU utilization right now 96%. Temperature on GPU 72 Celsius, means that GPU is thermal throttling. This GPU is thermal throttling starting with 58 Celsius. Keep that in mind. So your temperature should be below 58 Celsius or 58 Celsius if you would like to squeeze the maximum possible frequencies, because as you can see, this Titan RTX right now is overclocked. 100 megahertz additional on the GPU, so it should show us 2050 megahertz, but just because of thermal throttling, it's lowered the frequencies, and the VRAM is overclocked to 2000 megahertz additional through the MS Afterburner. In the end of this video, I'm going to show it to you. The game is beautiful. I really like it. And if you were my follower, then you downloaded this game for free, because I showed you how to get this game licensed, completely licensed and for free, this game over my YouTube channel. It was a special promotion for 7 days. So if you missed that, go ahead and subscribe to my YouTube channel and smash that notification button. There's a lot of more giveaways I'm going to announce. My personal giveaways, which is free, which is games that I'm going to give it to you for free as the gifts, as well as I'm going to show you if some other companies will do some nice giveaways. So don't miss that. It's you know, it's going to be great. Okay, ultra, not bad. 82 FPS. I'm recording this video today with the NVIDIA Shadowplay software, so it's pretty much consuming at least add 3 FPS to the FPS counter. If I'm not recording, it's exactly 3, as minimum 3 FPS. So you gotta add 3 FPS to the right top corner, and as you can see, the values of display information system updated every second, and it's very precise. Titan RTX today is running completely dual fan design NVIDIA stock cooling solution. And okay, they sent big guns. And I'm using the NVIDIA thermal compound paste, so I'm not using the liquid metal thermal compound paste. Please keep that in mind. Guys, I'm a good player in this game. This is my second time playing this game. I just warm up a little bit for like 5-10 minutes and check it out. And I really liked it, so I decided to go ahead and show it to you. And I got this game from that epic giveaway that I showed you guys throughout my community forum over my YouTube channel, UHDking.com. Hopefully you grabbed this game, because it was unlimited copies giveaway for like 7 days. So pretty much almost 90 FPS without the recording, and with the recording, it's, as you can see, it's going to be like 85 average, 87. Alright, look at that CPU utilization, 70 on average, like 70-75, and I'm using right now 12 physical cores. So I only disabled the hyper-threading technology in my Gigabyte X79 UD3 version 1.1 motherboard with the Gigabyte F20 BIOS, the only BIOS that is capable to run and post this enterprise Xeon E5 2697 V2 CPU on this gaming overclocking motherboard. And I overclocked my my CPU to 200 additional megahertz, and why 200 additional megahertz and not any more? Because the multiplier is locked. Okay, this video will be long, so go ahead and grab yourself your favorite drink. The best drink will be organic green tea with the lemon. It's gonna clean your system, and you will be healthy after 2 months drinking it every day. by watching my videos. So ultra preset, this is how we were running. Right now I'm going to show you how I would run it. So instead of anti-aliasing, I'm going to turn it off a little bit too low, and let's hope that it's going to boost up our FPS. And in terms of ambient occlusion, I don't need the ambient occlusion. Let's assume that I'm playing multiplayer. Let's go ahead and have a look what we can achieve. Are we going to boost up the FPS, or it just not going to be the case? So pretty much I'm assuming that they're using this similar game engine as Battlefield 5, because Battlefield 5 is also consuming a lot of CPU cores. It requires at 4K resolution 10 CPU cores, what I find out. And right now 80, I just saw 80% of my CPU usage, overall CPU usage. 80%, that means that 10 cores would give us almost 100% CPU usage, and this is 4K resolution. The higher resolution, the less CPU usage. So when I'm going to show you 1440p, you're going to see the CPU utilization will increase, and 1080p it's even going to be higher than that. The lower resolution brings us the lower GPU utilization, and we want to keep our GPU utilization as high as possible. So 97, I would say 97-99% is, oh, look at this dude. What up, dude? Are you dancing? Trip hop? What are you listening there? So yeah, so 97-99%, I call it excellent GPU utilization. When GPU utilization below 70%, that means that you're losing a lot of GPU shader cores or GPU CUDA cores, and it's idling. They're not utilized and pretty much a waste. And that means that if you will decide to run SLI and your GPU utilization below 80%, that means that your advantage will be just a little in SLI. SLI is great when your GPU utilization on a single video card is 95-99%. This is a great SLI. Scalability will be on two video cards, at least 1.8 times boost in terms of the FPS. Hopefully guys this makes sense. Oh, que paso, man? I'm going to die, look like. I just jump out to the wrong thing. Alright. So this is how I would play it, and we definitely boost up our FPS, as you can see, and increase our overall CPU utilization because I decrease the visual preset. And as I told you, when visual presets are decreased, the CPU utilization will be increased, overall CPU utilization, and GPU utilization will be decreased. So GPU utilization, I just saw 88, so pretty much average below 90%. So it's not great. We are losing about 10% of our GPU shader cores, and that means that it's about 430 shader cores lost or idling, not used, waste. And advantage of Titan RTX versus the RTX 2080 Ti will be 256 CUDA cores more on the Titan RTX than RTX 2080 Ti video card featuring. Keep that in mind. So pretty much Titan RTX is a hair faster than RTX 2080 Ti by about 10%, and when the RTX 2080 Ti is overclocked, it can match the Titan RTX, but Titan RTX can take advantage because Titan RTX has 24 GB of VRAM. VRAM is abbreviation for the video RAM, and that 24 GB or 24,000 megabytes is a huge difference when we're talking 8K resolution and above. As you can see right now, VRAM utilization is almost 16,000 megabytes, so this game consumes a lot of VRAM, and at 4K resolution. That means that RTX 2080 Ti most likely is not going to be runnable at these presets, or it's going to slow you down in terms of the FPS. But when it's 5 gigabytes above of the VRAM limitation, it still can run the game. It's just going to offload some data into the system RAM. And when it's going to reach 5 gigabytes of offloading data from a VRAM into the system RAM, you're going to see a lot of slowdowns and your FPS will be dramatically low when you're going to have the healthy VRAM utilization. Hopefully guys this makes sense. So pretty much almost 120 FPS. Average I would say 110 FPS without the recording and 1517 FPS with the recording. So it's a great... Uh-oh, this guy gonna get me. This guy's gonna get me. Alright, it's time to go ahead guys and switch it now. I'm going to show you high preset, and then I'm going to show you the medium and low, and then we're going to switch to 1440p and then 1080p. So okay, high, let's go ahead and have a look. So pretty much guys, as you can see, this is how I'm running, just switching the presets. The game looks very nice at 4K resolution. The visuals are amazing. I cannot say the same when I'm going to show you 1080p. As you can see, it's using DX12 API, and under the DirectX 12 API, the SLI is not supported. Multi-GPU is supported, but SLI is not supported. So if you want to run SLI, first of all, you gotta switch to DirectX 11 API. This is the first step. Wow, I'm good at this game. Look at this. I just warmed up for 10 minutes and I'm already good. And this is my second time playing this game. Dude, you gotta go after this dude. Like that. Boom, boom. ¿Qué pasó? ¿Por qué trabajo? Boom, boom. Oh, this dude with a shield. Amigo. Uh-oh. Uh-oh. Immediately, as you can see, our FPS dropped, by the way. I'm not sure why, because I'm using right now high resolution, so pretty much we should increase in FPS, but as you can see, my GPU utilization is also great. I'm not sure why it's 92 when it was ultra without the anti-aliasing. It was almost like 110 average. Maybe ultra without the anti-aliasing is kind of lower visuals than at high. And I played without the ambient occlusion. Yeah, I think it makes sense because ambient occlusion pretty much taxing a lot of performance on the Turing GPU architecture. Come on, dude. Turing GPU architecture is not scared of anti-aliasing, but pretty sure it's scared of the ambient occlusion. It's still scared of the ambient occlusion under DirectX 11 or DirectX 12 API. 90 FPS, not bad, not bad. Running very nice, by the way. Come on, dude. You can unlock all kind of different characters. As you can see, you can have all the way to 4 classes plus some custom characters. Oh, this dude gonna get me. But he gotta catch me. He gotta catch me first, but he's fast. As you can see, he's jumping. Jumpy dude. Alright, let me get some machine gun. Let's go ahead and give them some lesson, shall we? And then I'm going to switch to medium. because again 1080p and 1440p will be as extra. And I'm going to show you low preset because one of my subscribers, couple of my subscribers was asking me to bench it at low preset. So don't forget to smash that like button. This is an extra bonus for you guys. Alright, let me see that. Let me see. Where's the dudes? I picked up. Oh, right there, right there, right there. A lot of them. First of all, let's go ahead and. Oh, Jesus. This dude is fast. Can we get him? I think so, buddy. You're fast, but not fast enough. Okay, it's a victory. But I'm going to go ahead and reload the level real quick. It doesn't matter. It's going to be the same level. We're going to real quick reload it. As again, Titan RTX right now is overclocked, but it's still using the dual fan NVIDIA cooling solution, which is stock, and NVIDIA thermal compound paste. That is stock as well. I'm not using the liquid metal thermal compound paste yet on this particular Titan RTX in this workstation. I cannot wait to test on this workstation 2 Titan RTXs in SLI because it's going to run them 16x at PCI Express 3.0, while my gaming rig, my gaming PC, running it at a PCI Express times 8 if I'm running 2 Titan RTXs in SLI. So just to see how performance will be. I'm pretty sure at 4K resolution we're not going to see any performance boost when I'm running PCI Express version 3.0 8x versus the PCI Express 3.0 16x. But it's nice to see 8K resolution and above, such as 16K resolution. I think at that type of resolution there is a possibility that bandwidth of the PCI Express version 3.0 16x will show us who is the boss, because nobody tested yet at 16K resolution 16x versus 8x in PCI Express 3.0, and I cannot wait to see how it's going to look like. Wow, there is a lot of action, and we plenty 85 FPS average and above with the recording. Without the recording we're even higher than that, plus 3 FPS as I told you. And my gaming rig, guys, will show much higher FPS because it's 9 gen i9-9900K overclock at 5.3 GHz at 6 core 6 threads. But as again at 4K resolution we couldn't be able to run it at 6 core 6 threads because we're going to bottleneck our FPS. Our FPS is not going to be healthy. We're going to bottleneck our FPS with the CPU core needs and overloads. So probably I'm going to show 8 cores 16 threads or 8 cores without the hyper threading, just 5 GHz and 5.1 GHz. But that CPU is pretty much 9 gen, and this Xeon E5 2697 V2 will be a 4 gen kind of Core i CPU technology. So, and if you're watching my YouTube channel, you probably know the algorithm that I shared with you, that previous generation versus the next generation on the CPU, Intel CPU technologies, is pretty much you can add minimum 3% of the performance when you're running same frequencies and same amount of cores. Just 3% is minimum. So the 9 gen versus the 4 gen, it means the 5 generation ahead of this CPU. My gaming rig will be 5 generation ahead of this gaming of this workstation. That means that pretty much the 5 times 3, 15% of performance boost theoretically in FPS should be, and most likely it's going to be like in real live action, because we took the minimum, which is 3%, based on my experience, and I ran thousands of games, different hardwares, and that means, guys, that at least 15% of the performance boost in terms of the FPS. But we're going to find out exactly how it's going to be when I'm going to test the same game under the i9-9900K overclock at 5.3 GHz. But as again, that CPU is running additionally 2000 megahertz higher than this one, because this CPU is running 3.2 gigahertz as you can see per core, or 3200 megahertz per each core, as you can see at the right top corner, right? And what does that mean? What does that mean? It means that, come on, dude, come on, man. Right? This is what the our new current president says, right? Probably play too much of this game with vice president. She probably plays a lot of PUBG, I think, right? So yeah, so I would say it's additional 2 gigahertz per each core additionally will give us about 3-5 FPS additional boost. So I would say 17-20% of the FPS boost, probably this is what we're gonna get. Oh, this dude is fast. Alright guys, let me go ahead and switch now. We're gonna switch it to a medium, and you're gonna see the lower GPU utilization and higher CPU utilization, and we want to have the opposite effect. But unfortunately, when you switch into a lower presets, this is what you get. I don't think that they're using the ray tracing technology, because when this game came out, it was no ray tracing technology yet in 2017. So DirectX 12 API pretty much pointless versus DirectX 11 API. It's going to be the same visuals for sure. And what I find out, DirectX 12 is a little bit slower and utilizing, because it's utilizing a little bit more resources versus the DirectX 11 API. DirectX 12 API only makes sense when you are utilizing, let me get the machine gun, when you're utilizing the ray tracing, which is the RT features of the DirectX API. This is the only thing when you want to have it. Otherwise, you're just going to waste your resources, because DirectX 12 API consumes more of your video card resources than DirectX 11 API. Go ahead and watch my Serious Sam 4 video when I'm going to explain to you exactly. I'm going to compare the DirectX 11, DirectX 12 and Vulkan API. Go ahead and check it out over the UHDking.com or iplay16k.com YouTube channel, because I'm going to show you Serious Sam 4 running 16K resolution. And for you folks who's trying ask me how I'm achieving 16K resolution, pretty much I'm running 8K resolution native plus NVIDIA DSR technology 4X, but it's hacked through the drivers. Wow, look at this, FPS increased, of course, because we are running right now medium preset, and GPU utilization is still 95%, which is healthy, nice, 95, 96. But CPU utilization will be a little bit higher, so keep that in mind. Wow, not so bad, as you can see. And this game feels pretty much like a Battlefield, and it feels, it plays, and weapons also great. I like it, and visuals great. 100 FPS, so without the recording, 105 FPS average, not bad for 4K resolution at medium. Alright, let's go ahead and I'm going to real quick go ahead and show you now the low, because we have 2 more resolutions to go. We gotta be quick, I forgot, because we all don't have all day, so I gotta do something. I just woke up, guys, and even didn't brush my teeth yet, and didn't take a shower. So I decided, you know, yesterday I got this game, and I decided to go ahead and show it to you. And I got it as again for free, just like I shared with you. Hopefully you did it too. Still cool game. They have a lot of players online, guys. I check out the online and there is a lot of players playing online, and I think it will be a lot of players, especially right now, because they brought the fresh meat by introducing this game for free for 7 days, and completely for free. It's not just 7 days, it's during that 7 days you got it for free completely, and the game costs like $29.99. But as again, you can only get it for free if you're watching my YouTube channel. Okay, this guy is trying to get me, and he got me. Look at this. Superhero right here. Okay, we increased in terms of the FPS, 140 FPS average. Wow, 4K resolution. And as you can see, at low preset at 4K resolution, the game looks fantastic. A lot of details here. It looks better than 1080p, I would say, at high for sure. Wow, 150 FPS average for sure, even higher than that. The GPU utilization is still 95%, which is excellent, and not excellent but great GPU utilization. I called 92-95 great GPU utilization and 97-99 excellent GPU utilization. CPU utilization almost 90%. Oh, this guy's fast. We better be careful over here. Alright, dude, where you at? Where you at? Alright. When you see during the gameplay your CPU utilization reaching a lot above 90%, that means that you gotta add at least one thread, and it's better be a physical thread or a physical core. But of course, most likely you cannot add just one physical core. Most likely you can only add like 2 at least. And as again, only if your CPU supported and you disable it in your BIOS. And I only disabled the hyper-threading technology, so I'm running all the physical cores that is possible, which is 12 physical cores. Why? Because hyper-threading technology pretty much, guys, is on this particular CPU is 3.5 times slower hyper-threading threads than a physical thread. Keep that in mind. And you better run the physical threads to get the lowest possible latency delay and the highest possible FPS performance in PC games. Alright, because as you can see, my CPU cores is not fully utilized, so you can take the load. Alright, so not bad. Let's go ahead and go to 1440. Here we go. And yeah, let's go ahead and have a look, shall we? 1440, folks. Let me lower the presets so you can see what's going on, like that. Alright, here we go. So it's good. I'm going to start with low, and I'm going to go ahead and raise up the visuals. So it's low preset, 1440p. So pretty much this CPU is very comfortable. The gameplay is comfortable. Even at the ultra preset 4K resolution, it was comfortable, guys. Feels like 120 FPS even when I was showing like below 100 FPS at the ultra preset. Feels very great. Experience is amazing. And as again, the higher frequency FPS, the higher frequency CPU will give you higher FPS. This is simple mathematics. Wow, look at that FPS, 160. CPU utilization below 90, which is nice. GPU utilization right now is below 60%. So now we're wasting 40% of our Titan RTX video card, Turing GPU architecture by NVIDIA, TU102 GPU, means that 40%, pretty much we're wasting like what? I would say 43 times, because Titan RTX has 4,300 something, 306 CUDA cores, or 4,306 shader cores if I'm not mistaken. So pretty much 43 CUDA cores is 1% of the GPU utilization wasted. And this guy is going to go after me. Can he make it? I don't know. We're going to find out. Jesus. These guys are, look at them. Buddy, do you want me to give you some headshot? Right? You got it. Wow, 150 FPS, nice. Oh, you're gonna get me. The VRAM utilization is almost 15,000 megabytes, which is 15 gigabytes, pretty high. But I believe that this game doesn't have proper garbage collector, and it's still having, look at this, how ugly it is. You can see the aliasing on the floor at 1440p. And I'm playing on a screen above 70 inches, keep that in mind. And yeah, so I don't like to play below 4K resolution. But as again, this is for low budget PC builders, and we're going to cover everything during this video. Wasting a lot of GPU cores, and when it's like 40% idling or wasting, not used, it means, guys, actually it's dropping below 50% of performance, to be honest, on a Titan RTX video card, on this particular video card. Mathematically it's like 40% wasted or idling, but performance drop is like by 50-55%. Alright, and you can see that my GPU utilization is very healthy now. It's almost not thermal throttling. It's running 63 Celsius, but as I told you, it's starting thermal throttling at 58 Celsius. So it's supposed to be running 2050 megahertz, but it's running 2010 megahertz, so it's still a little bit thermal throttling. And what is the thermal throttling for those new folks that watching my YouTube channel? Thermal throttling is when the NVIDIA driver is lowering the frequencies on the GPU, and pretty much it's decreasing the performance, but decreasing the temperature as well. So at 1440p, Titan RTX is almost running healthy, as you can see. Healthy will be 57, 58 Celsius, but it's probably not going to be achievable on the dual fan design NVIDIA stock cooler and with the stock thermal compound paste. I'm pretty sure if you're going to put the Thermal Grizzly liquid metal thermal compound paste, you're going to lower your temperature by at least 3 Celsius, in most cases by 5 Celsius, but today I'm running completely stock thermal compound paste, stock dual fan designed by NVIDIA. And the best way will be to avoid any thermal throttling and running maximum frequencies on your GPU, which will increase the performance to the maximum possible potentials that is Titan RTX is capable, even higher than from the manufacturer. We'll be running this CPUs on water, on get water cooling or custom loop, but it's at least around $200 of investment, keep that in mind, on get water cooling, or around also around $200 on the custom loop, because you gotta buy a water block. This guy is gonna get me. Yep, he got it. Alright, so let's go ahead and switch to a medium. Alright. Wow, look at this. We increase FPS at medium. And why it is? Because we increased the GPU utilization. Look at that. We went from 60 to 70. percent of GPU utilization, and we increase in terms of the FPS, even running the higher visual presets. So GPU utilization is a very important factor for PC gaming. Keep that in mind. Oh Jesus, again this dude. Come on, buddy. I got him. Nice. Wow, guys. When the Titan RTX is not overclocked, my performance will be 10% slower, that you can see right now. 10% exactly. That means that around 10-14 FPS lower, that you can see right now when I'm running stock. Keep that in mind. Actually, I'm probably going to go ahead and real quick demonstrate it to you guys. Let me actually do that. So check it out. 169, 167, right? What I'm gonna do right now, I'm just going to lower to stock. So right now the driver is controlled. You probably can hear the fan is lowered down because the case is open. It's kind of noisy. And check out right now 162. So here we go. I was over here. 158, 163, 160. So most definitely will lower it by about 10 FPS. It was like 179, right? 176. Let me do it actually over here. It's going to be easier. See that 198 over here? Actually, I think the game is locked at 200 FPS, just like all the Frostbite game engine. And I believe they're running Frostbite game engine as Battlefield games, as you can see. And it feels like Battlefield as well. But it has also great visuals. And if you're into the Star Wars, it's a great game, guys. Great game. But as again, you gotta invest $29 for it. But you can find this game for around $10, $14 online. But if you would be a subscriber to my YouTube channel, you would get it for free, guys, forever. Let me get to some point when I'm going to show you right here. Jesus, hold on. Alright, so right here, guys, check it out. 176, 172, 173. Let me get to the point when it's not going to jump, so we're gonna find out exactly how much overclock is going to bring it to us. Let me get here, like here. Oh, it's high FPS. Jesus, I'm trying to escape so I can show you what will be the FPS when I'm gonna overclock back. I need to overclock back my video card. But there is a, let me get all the way here so nobody is going to be running here, right, like over here. So 176, 177, right? So this is at the stock. And now I'm going to back to overclocking. As you can see, 1000 megahertz additional on the VRAM, but because GDDR6 times 2, 2000 megahertz, so from 14,000 megahertz to 16,000 megahertz, and 100 megahertz on the GPU. Let's go ahead and bring it back. Check it out. This is a safe home environment, stable on air overclock. 187, 88. See that? Okay, let me run it again. And I'm going to increase the visual preset, and we're going to keep moving. Cannot wait to test 8K resolution on this game. But FPS probably will be low, but I still want to see on a single Titan RTX. I'm pretty sure if this game is going to support 2 Titan RTXs, 8K resolution will be stable 60 FPS. It could be under DirectX 11 API. I didn't try it yet. And as again, guys, there is a possibility that on the i9-9900K overclock at 5.3 gigahertz, I'm going to reach during this test 200 FPS, which is, I believe, the maximum FPS for this particular game, because this particular game engine doesn't have unlocked FPS. It's still locked at 200 FPS, I believe, if I'm not mistaken. Okay, Jesus. so many of them. Alright, so what we're gonna do now, we're going to pretty much bring the resolution up from medium to high, and then ultra, and then I'm going to switch to 1080p. Come on. Why I'm recording at 30 Hz? Because somehow 1440p on this particular screen is locked in this particular game at 30 Hz, and I can switch 4K resolution at 60 Hz, and I can switch. I'm running a TV, by the way, and 8K resolution, and I can switch to 1080p at 60 Hz, but 1440p locked at 30 Hz, and I'm not sure why. But if I would be recording this, pretty much when I will be switching from 4K resolution 60 Hz to 1440p 30 Hz, it would pretty much just give me the this guy is crazy. Just give me the shutter play recording stopped on me, and I don't want this to happen. I'm gonna get him. Nope, he got me first. And yeah, I just want to take it as one take, guys. I'm not going to edit this video at all, as I told you, I'm coming in real time. And as again, if I would be recording this video with the external video recording device, oh my god, I'm gonna die again, guys. Or maybe not. And my FPS will be at least 3 FPS higher that you can see right now, so add 3 FPS. Wow, we increase. I think we increase. Nope, we didn't increase in terms of our GPU utilization. GPU utilization is still low. It's still below, guys, 90%. So the lower resolution, the lower GPU utilization, and pretty much the lower FPS. Because at the lower resolution, CPU utilization will go higher, but GPU utilization will go lower. And we want to have opposite. We want to have the CPU utilization lower and GPU utilization higher, so I can run frequencies above 3.2 gigahertz. With 4 core 4 threads is going to be 3.4 gigahertz, and 2 cores 2 threads is going to be 3.6 gigahertz. But unfortunately, it's not possible for this particular game. For 8K resolution, however, it could be possible to run 4 cores. We're going to find out. But in Battlefield 5 8K resolution, it's not possible to run 4 cores, because your total CPU utilization will reach to above 90% a lot of times, and that when it's reaching above 90% a lot of times during the gameplay means that most likely you're limited in terms of your FPS, and you can push higher FPS if you're going to just add a single more, just one more thread or physical core. The best way will be physical core, of course, for the best possible effect on the FPS. Still great FPS, guys, above 150. Wow, 1440p is comfortable on Titan RTX. VRAM utilization is 14,000 megabytes, as you can see, which is 14 gigabytes. But as again, I believe it should be lower than that. If I'm going to do a restart of the game, it's probably going to go lower than that. And just because the garbage collector of the VRAM is not working properly in this game, and when I'm switching the resolution, it's probably kept the data in a VRAM that left from 4K resolution and didn't clean it through the garbage collector. That's why my VRAM utilization is so high. Keep that in mind. Dude, come on, what are you doing there? Alright, that's pretty much high preset. Let's go ahead and switch it. I don't want to keep this video like 2 hours. So high preset was like that, right? 1440p. And now I'm going to show you ultra. And then after ultra, I'm going to show you how I would play it. So it's going to be no ambient occlusion and no anti-aliasing. And what is the ambient occlusion? Ambient occlusion, pretty much, guys, it's like fake shadows around every single edge on the 3D model. It's like inner shadows in Photoshop on each layer. Just kind of fakey shadows around the 3D object edges. Like over here, as you can see, fakeish here, and some lightish there. So kind of faking the lighting effect as best as it could. Emulation, I would say, not fakeish, but emulating. Alright, time to switch. Let's do that. So this is the ultra, guys, pretty much. Let me a little bit more. Let me show you just a few more seconds. As you can see, my GPU utilization is still pretty low, below 90%, and CPU utilization kind of went maybe a few percent lower than it was, but still very high, like 85%, but healthy CPU utilization. We didn't need additional cores. They're not going to bring any benefits. They're not going to bring any FPS. Keep that in mind. Guys, a lot of 8K resolution, 16K resolution is coming to UHDking.com YouTube channel or iplay16k.com YouTube channel. You don't want to miss it out. It's going to be a great videos. And more giveaways coming to my YouTube channel as well. Don't miss it out, guys. And pretty much you want to subscribe. You want to read all my community forum messages and watch all my videos fully. The next game codes will be integrated into the videos. Some of them will be integrated into the community forum. I did a lot of games for free, giveaways of my own money that I spent throughout the holidays, such as Christmas and New Year. I did like 10 games, and I have a lot of winners. So please support me, visit my sponsor. So I'm going to do more giveaways because I'm investing my YouTube money back to you guys. Jesus, a lot of action, a lot of action. Who's that guy? Fancy Monkey? Alright, so let me go ahead and show you how I would play it now. And pretty much maxed out 1440p, but I don't like to play 1440p, especially on Titan RTX. To play 1440p, there is something wrong with you, because as you can see at the right top corner, you pretty much wasting by idling that shader cores on the GPU. So I would pretty much do ultra, but go custom, and I'm going to turn on the ambient occlusion and anti-aliasing completely. Let's go ahead and have a look if we're going to improve the FPS. So pretty much still ultra visuals, a little bit tweaked out, still maxed out almost. 120, above 120 FPS average. Without the recording power, almost 140 FPS, which is nice. Already you can see that missing details in terms of the pixels right there. When you're playing 4K, you can see the details right there. Please watch this video, guys, 4K resolution for the maximum possible experience. And right now it's missing, but when I'm going to play 1080p, you're gonna see a lot of pixels of details will be missing. Pretty much it's just not rendered. Like this right here, column right here, probably have like at least 2K resolution or 1080p textures, and right now on my screen at 1440p, it's about 512 by 300 something pixels. Means that we're losing a lot of details of the texture on that column. Alright, this Fancy Monkey, I remember this dude. He's kinda, oh, look at this. He got some superpowers. Wow. Reptile. Very comfortable, guys. but also comfortable at 4K. So I would probably play 4K instead of 1440p. Alright, so let's go ahead and switch now. So I showed you guys all kind of different preset. This is how we were running 1440p maximum visuals, but kind of my preset. Now what I'm gonna do, we're just going to real quick go to 1080p. Here we go, 30 FPS, nice. And we're gonna start with maximum possible preset, how I would be able to run it in this game, and because with my taste. And then I'm going to go ultra high. Wow, look at this, the aliasing, I can see it a lot, and textures right there is ugly, pretty much almost plain, not the details. So this is the difference, guys, 1080p versus 4K, and it will be even same kind of difference, 4K versus 8K. 8K will be amazing, and above 8K it is going to be just amazing. All the details at far away will be just like you close to them when you're playing above 8K. But I think this game probably going to be runnable 10K resolution on a single Titan RTX. Probably benchable, not playable. But I don't think this game will be runnable on single Titan RTX at 16K resolution. But I will go ahead and try it. So go ahead and smash the like button for that. I will go ahead and try it at least. If it's going to be runnable 16K resolution, or playable, or benchable. So we can compare with the future PC systems, with the future GPUs and CPUs. So the purpose of this video, guys, as you can see, is not the gameplay. The purpose of this video is just benchmark, pretty much, and show you what it is, especially if you're building this computer. Kind of similar low budget system with the Xeon E5 2697 V2. But most definitely you don't want to buy right now in the beginning of 2021 Titan RTX video card. Titan RTX video card in the middle of 2022 will cost around 600 bucks, and this will be the nice time when to buy two of them and play 8K resolution, because two Titan RTXs in 8K resolution pretty much is capable to run above 60 FPS in 8K resolution in the games that was introduced to us before 2020. Before 2020, games can capable to run two Titan RTXs even on this old school Xeon CPU at 4K resolution at average 60 FPS plus, and everything is just amazing at that level. Okay, so 1080p, you're probably not gonna see this aliasing if you're going to watch it like on a small screen and on a YouTube, because YouTube going to bring that kind of blurriness while it's going to do the transcoding, and we encoded this video to lower bitrate video. Okay, they got me. Wow, look at this, look at that FPS. FPS is kind of the same as 1440p, and as again, why? Because the GPU utilization, very important, below 60% of GPU utilization. So right now, if you're going to add two Titan RTXs in SLI, most likely you're going to be at the same FPS like when you're running a single Titan RTXs, because you don't want to add secondary Titan RTX or create SLI setup when your average FPS per single Titan RTX is below 80%. It does make no sense. Unless you're going to pretty much set the higher resolution, so it's going to be higher GPU utilization, and then added the secondary or more video cards in SLI. Definitely Titan RTX only support two-way SLI technology by NVIDIA. Alright, so you saw the FPS. Let me real quick go ahead and switch it. I'm going to switch it real quick to, let me see, to ultra preset, I would say. Let's go ahead and do that. Ultra preset, 1080p at ultra preset. Let's go ahead and have a look how it's going to look like. I'm going to upload this video, guys, tomorrow for you to see, like January 22, 2021. Hopefully you're enjoying that. And if you're into Star Wars and kind of first-person shooter like a Battlefield, this is a great game for you guys. Feels solid, the guns feels great as well, and they're not so complicated as you can see. So it's easy to get with that and enjoy the game, and doesn't cost the fortune, even if you didn't get it for free. Wow. Below 55% of the GPU utilization. This is very low, and FPS is low. FPS should be over here at 99%, probably like 220. But this is not the case, and is again because the very low GPU utilization. That's all. CPU utilization below 90%, so healthy CPU utilization, still healthy. Even if couple seconds, if it's going to go to 90, it's still healthy. CPU utilization, and it's going to be healthy FPS. The FPS is not going to be bottlenecked by the CPU, even if CPU will go like 1 or 2 times to 90%, as I just saw 91. Very low latency delay, and that milliseconds, guys, close to the FPS at the right top corner. It's a latency delay between the hardware and software, and latency delay we want to keep as low as possible value, while FPS we want to keep as high as possible value. So ultra 120 FPS average though, not bad. But as again, single RTX 2080 will give you guys a high FPS, because you're going to utilize that video card probably at 97% at 1080p, the single RTX 2080. The RTX 2080 Ti will show you guys the same performance almost, because it's pretty much the same video card as Titan RTX by about 10-15% slower. But when RTX 2080 Ti is overclocked, it's going to be equal or hair slower than Titan RTX running at stock. Alright, let's go ahead and play it again, and I'm going to switch to high. So pretty much for this game you need a lot of CPU cores, guys. Quad core is not going to give you the healthy FPS. Keep that in mind. Oop, I selected the wrong character. Yeah, the 1080p, look at this. I didn't see no details right there at that distance, but 4K was showing us the difference, and 8K resolution will be all detailed, and 16K resolution everything will be detailed. But I don't think that 16K resolution is possible while running this game on a single Titan RTX or even 2 Titan RTXs, because I think the VRAM will be overloaded. But as again, to find out will be the only to try it, and I'm going to try it and report it to you guys. This is my first time, as I told you, to run this game, so I didn't try it even at 8K resolution, so I have no clue. But if it's going to be runnable 8K resolution, I'm pretty sure it's going to be runnable 10K resolution, and after that point we're going to be limited only by the VRAM, which is our video RAM on the Titan RTX video card. And usually when VRAM doesn't go above 24,000 megabytes, because Titan RTX has 24 gigabytes of VRAM, and when it's going to above 23,000 megabytes on the VRAM, pretty much is going to offload a lot of data into the system RAM, and you're going to see that system RAM will raise up like crazy. Right now system RAM below 12,000 megabytes, as you can see at the right top corner. So healthy system RAM usage. Anyways, again, the game is gorgeous. Even at 1080p with aliasing, it's still great. Alright, so let me go ahead and switch. Because guys, I gotta go. I gotta do some other stuff today. Ultra preset, so I'm going to switch to high. Okay. So our CPU utilization will raise up, and maybe we're going to go above 90% when I'm going to run the 1080p at low. That means that we're going to waste a lot of shader cores or CUDA cores on our GPU. So you can see right now our GPU is running 2010 megahertz. The temperature is 60 Celsius, almost very healthy temperature, almost without the thermal throttling. Still a little bit thermal throttling, but almost without it. And CPU utilization below 90%. It just hit at 90%, but pretty much all the time below 90%. But GPU utilization is below 60, so we're wasting a lot of shader cores, a lot of those CUDA cores on the Titan RTX GPU, which is TU102 Turing GPU architecture by NVIDIA. Wow, look at this. And this guy's running so healthy, so well. Liking it. Okay, that dude is dangerous. We better get that dude. He's like a transformer. So only like 130 FPS. Wow, with 1440p you are receiving higher FPS than that. And just because you're running the higher GPU utilization, that's all. This is how much difference the GPU utilization can make, guys. And of course RTX 3090 will show you the same VRAM utilization, but I'm pretty sure that it's going to show you the higher FPS. Probably it's going to show you almost 200 FPS running 1440p, because even with the less GPU utilization, it's still going to show the higher FPS because it has more CUDA cores on it featured on the GPU than Titan RTX video card. Keep that in mind. And I don't think that RTX 3080 will be able to run 4K resolution maximum visuals. It's going to be very, I have a doubt, very kinda unhappy FPS probably. Alright, so what we're gonna do now, I'm just going to switch a different preset. So medium. Yeah, definitely garbage collector doesn't work in this game, as we can see. Just, this is the enemy, alright. See, 1080p is kind of hard to see because a lot of things pixelated. And I'm talking when you're running above 55-inch screen. And of course the YouTube re-encoding will bring some blurriness to it, and it will pretty much smooth out the pixels of those aliasing if you're watching it on YouTube. But as again, please watch 4K resolution. Maybe you will be able to see what I'm seeing right now, but it's pixelated. It's not an excellent experience. Come on, come on, come on, come on, come on, come on. We gotta get this dude. We gotta get him. Oh, look at this. He was running circles around. Oh, wow. Yeah, 90%. I just saw 90% CPU utilization. At low, it's going to probably stick at 90%. But GPU utilization below 60. A lot of games, guys, I recorded on this Xeon E5 2697 V2, so a lot of content for you, and a lot of games on the Titan RTX video card on different type of systems. You don't want to miss it. But as again, you want to get this Titan RTX as used like new on eBay at the great price, and great price will be like 600 bucks. So two of them will cost you like $1,200, $1,300, and enjoy 8K resolution at 60 FPS. Games that was released before 2020. You're going to have a lot of fun. Let me tell you, a lot of fun. Okay, medium. Guys, don't forget to add 3 FPS to the FPS counter without the recording. Alright. Running great. 1080p, 1440p, and even 4K resolution is running very comfortable, guys. Because you saw the lowest latency delay, but the higher resolution, the latency delay goes higher, and pretty much high FPS as well, no matter what resolution you're running, from 1080p to 4K resolution, which is nice. Alright, look at this. This body is dangerous. Boom. We gotcha. Houston, we gotcha. Boom. I got him. Alright guys, let's go ahead and switch the preset now. You saw the action, the preset. So now I'm going to go low, and that's it. After that point, we're gonna go ahead and wrap it up. Oops, not here, right over here. Low preset. Okay. Okay, buddy. You're running into the shotgun, huh? Wow, 160 FPS, nice. CPU utilization, as you can see, at the high 80s%, and GPU utilization is still actually below 50% now, so we're very low on our GPU utilization, like very low. And we increase our GPU frequency to 2025, but I told you it's supposed to run 2040, but just because we need to decrease the temperature on our GPU, and it's going to be below 56 Celsius. Not 58, but 56, and I believe below 56 Celsius it's not going to thermal throttle. But as again, if you want to get rid of this thermal throttling, get yourself a ghetto water cooling or set up the custom loop, but it's kind of expensive. Alright. Oh, not again. Hi guys, I think pretty much one more minute and we're going to go ahead and wrap it up. I think I showed you everything what you need to see for your own analysis. Too bad that environment is not destructible, as you can see, but the visuals are not great, so I can understand why it's still utilizing a lot of FPS. Alright guys, I showed you pretty much everything what you need to see. A lot of action and stuff. Let me go ahead and quit. And let me show you what kind of system I was running today. So this is my system. Let me open the GPU Z. Okay. So guys, this is my system, as you can see, and CPU utilization was healthy. We never reached a single CPU at 100%. It was evenly split, as you can see. And additional cores at this type of scenario are not going to boost up our FPS in PC gaming. By adding additional cores for the maximum possible benefits, you want to utilize all of those cores at 100%, just like I'm doing it on this workstation when I'm doing the video encoding, 8K resolution to 8K resolution for you guys to a lower bitrate, or 3ds Max 3D rendering. So here we go, 12 core 12 threads, so not 12 core 24 threads, but 12 core 12 physical core, threads, 3179 megahertz, which is 20 megahertz below 3200 megahertz. Great how I achieved that. Otherwise it would be running, as you can see, 3000 megahertz or 3 gigahertz, because it's running 30 multiplier, and multipliers again is locked no matter what motherboard you're using on this particular CPU, which is the Xeon E5 2697 V2, and it doesn't matter, any E5 2600 series V2 CPUs will be with a locked multiplier and the X79 chipset, Saka 2011 V1. So and it's splitting between the 12 core 12 threads, 30 megabytes of level 3rd cache. Okay, this is what's up, 16x on PCI Express 3.0. Let me see. The DDR3 was running 14,013 megahertz, CL7, unheard of, and it was running stable, guys. I found how to stable it, and I'm going to come up with a video tutorial how to overclock this CPU under the Gigabyte X79 UD3 version 1.1 motherboard. So stay tuned if you're using the same motherboard and looking to buy the same CPU. As you can see, I replaced the CPU on my i7. I used to have i7 4930K overclock at 4.2 gigahertz, but it was 6 core only, so I sold that for $100, used like new on the eBay, and invest another $29 and got myself this CPU, which additional 20 pretty much total 24 threads, which is 24 virtual cores, and it's amazing, especially when they all scaled. Yeah, so CL7 though, this is the fastest possible thing for this CPU CL. This is the graphics. Oops, right here. So 8000 megahertz on our VRAM GDDR6, and this is how Titan RTX is running. Let me go ahead and bring it to stock. And when I'm going to bring it to stock under the GPU Z, you're going to see that pixel fill rate ratio or value will go to from 179 gigapixels to much lower value. Textile fill rate value from 538 gigatexels will go to much lower value, and bandwidth, which is our VRAM overclock, will go way below 768 gigabytes per second. But it is what it is. And this is the IDA64 benchmark, which is cache and memory benchmark. We want to make sure that we want to keep our eye at the latencies, because they're going to be unchanged even if I'm going to add the hyper-threading technology or disable it. And with a different type of system RAM, those latencies in terms of nanoseconds will be different. And as you can see, it's improved. I showed you in one of my videos 2 core 2 threads, it was like way below 30,000 megabytes, and right now we are above 30,000 megabytes, which is 41,738 megabytes. This is very crazy. And of course the data transfer, read, write, and copy, when you're going to add additional threads such as hyper-threading technology, will improve over here, of course. And this is the IDA64 GPU benchmark. Okay, and let me bring it, guys, to stock. Boop, stock. Check it out, those values that I told you. First of all, 7000 megahertz over here on the GDDR6, and core frequency decreased as well. Let me open up the IDA64 as again and check out all those values that I showed you that are going to decrease itself. Yep, right here. So 169 pixel fill rate, textual fill rate 509, and bandwidth 672. So way more than 10% was decreased, but performance was 10% exactly, not above that. Okay, that's it, guys. I think I'm going to go ahead and wrap it up. As again, thank you so much for watching. For those who's curious, the last deal, let me show you the IDA64. I'm running very low voltage on my CPU right now, which is amazing. And I finally learned how to keep my DDR, instead of 1130 megahertz, all the way to 14,012 megahertz, and it's stable, rock stable. As again, if I'm going to record video tutorial using the external video recording device in the BIOS, then I'm going to show you the best tutorial on Gigabyte X79 chipsets, guys, with this particular CPU, which is the flagship of the E5 2600 V2. And this is the workstation from 2020. Keep in mind that in 2021 I'm going to replace it with two Xeon E5 2699 V3. Total 72 virtual cores output with hyper-threading technology enabled. Unheard of. Unheard of. That's it. This is the technology and CPU real quick. CPU IDE. Go ahead and study it for those who's curious. All the supported technologies and features by this CPU. Okay. Of course, read, write, copy. Everything that is not in blue color is going to be my previous system, such as in the light green color, and yellow will be my system, the kind of dark yellow. So in orange, kind of yellowish, it's my current system. Great boost, guys. Maybe not as workstation when you're going to disable the hyper-threading technology, but most likely as the gaming system for sure, if your overall CPU utilization below 90 and never reach 95%. For sure, you're good to go with this type of course. And I can enable hyper-threading technology in the BIOS, but I don't want to do it because it's 3.5 times slower than a physical core, and it's going to bring down my FPS. Okay. Alright, so this is what's up, guys. Alright, thank you so much for watching. Don't forget to smash that like button. A lot of time, money, energy was invested. Subscribe and share it with the friends, guys. And have a great day. Stay safe. Till the next time.